Cool. Okay. Start again. So thank you very much for joining me for this last session of the day on mastering PowerShell testing with Pester. So I'm hoping that you guys have seen some really inspiring stuff throughout the day. I know I've seen some really interesting talks, and I think I'm biased, but I think you've made the really smart choice of using this as your last session because if you're going to write some really interesting PowerShell after today, you want to make sure that it works, and that's what this session is all about. So actually, before I start, I wasn't going to do this, but quick show of hands. Who's used Pester before? Okay, cool. And who's used Pester specifically to test their PowerShell code works versus testing? Okay, all right, cool, slightly less. All right, good. That's sort of what I expected. So real quick thing about me. I'm on Twitter and I have a blog that I don't post to very often. And I've got some projects on GitHub, and I'm currently working as a DevOps engineer for xe.com. But yeah, as this Pester output says, you might have expected the foremost expert in Pester, but unfortunately you got Mark Wragg. I don't consider myself the foremost expert. I've never contributed to the repository. I've never contributed to the code, but I sort of consider myself as its biggest fan. So I've been using Pester for about 3 years, I think, and a kind of colleague, friend of mine introduced it to me, and at the time, I was kind of reflecting the other day on kind of what were my feelings when I first discovered Pester, if you've never used it before, and at the time I was kind of like, oh no, what is this? I was at the middle of sort of struggling to learn PowerShell, and what I felt like I didn't need was another thing on top of that to worry about, and a whole nother kind of what felt like an independent language to learn. But the reality is actually Pester's relatively simple, and I'll show you that. And it's incredibly powerful, and it's incredibly important. So yeah, that's kind of where I've come from. So on to about Pester. So Pester is, if you've never touched it, Pester is simply a PowerShell module for testing PowerShell code. So it creates, it's been mentioned in a couple of other talks, but it's a DSL that basically defines kind of how tests should look, how they should be structured, and it just allows you, it gives you a nice way in which to craft tests for PowerShell and with PowerShell, and it gives you a nice way in which to run those tests and see the output. So Pester, I believe, I was going to check, but I didn't, but I'm pretty sure that the Pester module itself is just written in PowerShell. Now yeah, cool, thank you. Some PowerShell modules are written in C#, and I'm like, I don't do C#, so I can't contribute to that. But Pester is just written in PowerShell, so if you're confident enough with PowerShell, there's no reason why you couldn't make a contribution to the Pester project on GitHub. And more fascinating than that, it's used to test PowerShell core. So if you go look at the open source repo for PowerShell core, you'll find Pester tests in there that test the way the commandlets of PowerShell core work, which, like, to me, that's more confusing than the timelines in the Terminator films, because it's like PowerShell was written, and now Pester was written with PowerShell, and now Pester is testing PowerShell, and I'm not really sure how that works. But it also tests itself, which again, a little bit AI gone rogue, but the tester module itself has a set of Pester tests. So when, I guess it's previous version testing new version, it's really well used in the community. It's very popular. Microsoft are very much invested in it, as is shown by the fact that on Windows 10 and Server 2016, I believe, they bundled it in. So sorry, it comes pre-installed, but on Windows 10 and 2016, you should still update it because it's fixed. The pre-installed version is fixed to like 3.4, 3.5, and we're now on like 4.4. And particularly that move from version 3 to version 4, they made some fairly significant syntax changes, which are backwards compatible. But all of the code samples I'm going to show you today reflect the latest version of Pester. So if you haven't got it, you can install it from the PowerShell gallery on any operating system. I say on the operating system as well. It's cross-platform, so it's PowerShell core compatible. So you can use it on Mac, which I am today. You can use it on Linux, Windows, and it also, I think it works way back to PowerShell version 2. So it's a really, really broadly compatible module, which is incredibly impressive. So Pester is a versatile tool that can be used for a variety of testing strategies. So some of the other talks that I've been to today, and I've tried to kind of follow the testing specific talks for tips, but there are lots of different ways in which to use Pester, some of which are these. These are kind of quite standard testing strategies. You can do operational validation, which is kind of like, is my system configured the way I expected it to be, or is my application working the way I expected? Are ports open, are services running, which is a really, really nice way. If you haven't used Pester before, that can be a really nice way to get into Pester and to learn it as a language, because if you're in a more traditional ops role, or in a business where you've got manual checklists after you make a change or after you install some software, Pester is a really good tool to use to replace that manual checklist with a series of Pester tests that make the same checks. And immediately you've taken kind of like what might have been an hour of manually checking, turning into sort of 30 seconds of running a script. So that can be, the value that you get back from that is really immediate and really obvious. Another kind of testing is integration testing, and integration testing is the idea of, your code sometimes is part of some bigger system, and it's about when you change your code, does it still integrate correctly with the other parts of the system? So it's sort of looking at the system as a whole, and it's also kind of looking at, your code itself might be made up of a number of individual pieces. Integration testing is kind of the idea of looking at the outcome of your code. So from the outside, does it do what you expect overall? And then unit testing, which is really the focus of this talk. So unit testing is the idea of you're breaking your code into the smallest possible pieces. Each distinct action that your code performs is a unit of code. That doesn't necessarily mean it's a single line. You can have kind of multiple lines of code that achieve one result. The Pester was originally designed to be used to kind of test those units, to do unit testing, to test each unit of your code. So that's really the focus of this. So why should you bother? I want to get to Pester fairly quickly, but I want to use this talk to really kind of sell people on this is something that you should be doing if you're not already. Because I found this quote on my company's internal wiki, and I don't know who wrote it, so I can't credit them with it, but somebody wrote on a doc internally, testing is the single most important thing you will ever do, and I really like that. It's very, very true, because it can save you so much time up front and so much, save you from so much pain further down the line. The reality is you're already testing your code. So Pester just allows you to be more detailed and thorough with that testing. Every time you are writing some PowerShell, I'm sure you're running it at the end and probably throughout. No one's writing some PowerShell and then going, yeah, that probably works, I won't run that. Maybe they are, that'd be amazing. But I'm sure you're not. I'm sure you're writing some PowerShell and then you're running it to see if it works, but you're running it in one way, maybe two ways, and you're seeing whether it kind of, you've got some idea of how you think it should work, but every time you make a change to it, you're running it in those one or two ways. Pester is about having, much more detailed, much more thorough tests that run very quickly. You build them up over time, but then every time you make a change, you can apply those tests. There's obviously been lots of talks about DevOps today, and it's perfectly possible, and I really encourage people to build CI/CD pipelines around your PowerShell code and around your PowerShell modules. It's possible. So CI/CD, continuous integration and continuous delivery, it's this idea of an automated pipeline that I have some code that I ideally live in source control. I modify that code, and when I modify that code, it kicks off a pipeline that basically says, oh, I've seen you've changed it. Okay, I'll run a set of tests to see if your code is still functional. Okay, your tests will pass, great. I'll push your code into production, or I'll push your code into a package repository like the PowerShell gallery that allows you to then deploy your code when you want to. So that's a really cool goal to get to with PowerShell. And if you want to achieve that, tests are, of course, a prerequisite to that, because you can't know whether your code is safe without this automated testing being part of the process. So yeah, learning testing is a prerequisite to CI/CD. And then text, this is a little bit tenuous, but your tests kind of act as a form of documentation, not exclusively so. Anyone who's like, well, I've written some tests, so you should know how my code works. They supplement your documentation. Of course, you should be writing help and other documentation around your tools, but tests help show, they demonstrate how you as the developer imagined that the code would be run, or intended the code to be run. And that can be really informative to someone who potentially ends up picking up your code after you, and you haven't died, maybe you've changed jobs, and they've adopted your code, and tests can then be really informative in helping them to understand what it was you intended them to do. As I say, you the developer, I was just in the DevOps talk previously, and in that there was a brief mention of imposter syndrome. Beware of imposter syndrome. A few years ago, I started answering questions on PowerShell questions on Stack Overflow, which is great. It's a really nice way to kind of test how confident you are with PowerShell, and also learn a lot of things and find a lot of interesting questions that people are asking about PowerShell. But Stack Overflow, once a year, do a developer survey. So they contact all the users and say, please answer all these questions about what it's like being a developer. And I often thought, well, I don't know if I count as a developer because I'm just doing PowerShell, and does that make me a developer? And I've decided that I am, and I've decided that you all are as well. So if you're really anyone who is capable of converting coffee into code is a developer, if you're writing code, if you're writing tools, even if you think, I've just written a few lines of PowerShell and only I'm ever going to use this, you might find 2-3 years down the line that piece of code that you thought you were the only person that was ever going to use is now this key part of your business and is underpinning and is making or breaking your business's survival. That's an extreme example, but I think it has the potential to happen. And I think that PowerShell people tend to come from a sysadmin ops type background, and as a result of that, don't necessarily feel like, well, certainly don't get the developer training and the developing skill set around what it means to be a developer, including writing and maintaining tests as part of your code. But I think that in the near future, we're going to see Pester, if they're looking to hire a PowerShell person, they're looking for that PowerShell person to know Pester, because there's a certain level of responsibility around the code that you write being safe to use and proving that it works. So yeah, you developers, congratulations. So one last thing before I actually start talking about Pester, and I've written this PowerShell code maturity model, which I made up. Now, this is sort of the journey I went on. It's not necessarily the journey everybody goes on. You can skip stages quite easily, but a lot of people tend to kind of go through this journey, which is they discover PowerShell, and they start, by the way, this is the most grown-up slide in this whole talk. So you discover PowerShell, and you start just hacking one-liners into the console, and you enjoy chaining commands together with the pipeline. And then you're like, OK, I've found some useful commands. They're quite complicated. Don't want to have to remember them. You start saving those commands as PS1 scripts. And then you might discover that there's this thing called functions that allow you to kind of make bits of your code repeatable and clever. And so then you start chucking some functions in your scripts. But below those functions, you have some lines of code that just immediately invoke those functions and run them. Then you might decide, well, actually, these functions are useful as kind of tools. They're my own commandlets. I could just chuck a load of those in a PS1 file, and then I just run that PS1 file, and suddenly I can call my functions when I want to. That obviously leads to a point, well, if I'm sticking them in a PS1 file, I should just be sticking them in a PSM1 file and using it as a PowerShell module. So when I want to load it, I'm using import module to load them. And then, I mean, what happened to me was I was doing some Googling around, well, how should I be laying out my modules? And I think there was a talk on this earlier that I missed. But one of the, Richard Sidaway might not be happy, because one of the best practices is organizing your functions into individual files, which is just nice from the perspective of, particularly when you start to collaborate. Well, firstly, because if you've got like 10 functions in one file, finding the one you want to maintain can be a pain in the arse. And so having them in individual files makes it really easy to find them. And I love looking at my file system and being like, oh, I can see all of the functions that I've written for this module. So organizing them into individual files is kind of a next evolution of your code maturity. And then, OK, well, now all I have to do is slap a manifest on top of that, and I can publish it into the PowerShell gallery. And then, OK, well, it's going into the PowerShell gallery. I can automate that through CI/CD. I can have tests that run automatically and publish it when I change it. So that, I think, is kind of start to finish. The reason for this slide is you need to be in this stage. You need to be kind of at the fourth stage or beyond for your code to be testable. And that's because Pester needs to be able to run your code without running your code. It needs to be able to load your code, and then it needs to be able to control when pieces of your code run so that you can test them under test scenarios. If you have a PowerShell script that is a PS1 file with a load of commands, Pester can't really test that, because when you try and load it into your Pester test script, it's just going to execute, it's going to run. So it needs to be, your code needs to be wrapped in functions. That's not to say that you can't have PS1 scripts with commands that just run, but maybe you've got a load of code for those scripts that are in functions, and then you can at least test that functional code. And also, it is maybe possible, there are dirty workarounds to testing at this layer, but ideally you want to be here, and even more ideally, you want to be in individual files, because it means you can kind of pick an individual file to test on a one-to-one basis. So, how long was that? All right, that's not too bad. So this is Pester. This is the 5 Pester commands that one of the maintainers of the project called out as the 5 kind of most important commands that you need to know. And in fact, actually, you only need to know 3 of these. So these are kind of keywords. To use Pester, you need to just know some new keywords and some structure that you need to remember to use. And so these are them: describe, context, it, should, and mock. And only describe, only describe and it are really important, and should is quite important. But aside from that, Pester is just PowerShell. So they're still just PS1 scripts. And you can stick PowerShell into your Pester scripts any way you like. So if you want to kind of, and I've done this in the past, if you want to have kind of 10 tests that do something, you don't have to necessarily write 10 tests. You could have a for each loop that kind of pulls some data from somewhere and tests the same thing in 10 different ways. So you can use the PowerShell that you already know any way you like within your Pester scripts to make them more dynamic, to make them more clever. So it's only a little layer on top of that. So let's look at an example. Oh, I'll try not to cough. I don't want to kill the microphone. So this is a really simple example. This is kind of like the hello world of Pester, because you often see this used as an example of how to write Pester. So imagine that this function at the top is actually in its own file, which I will show you when I execute this in a sec, because, of course, I don't want my test code to be immediately under my functional code, because then every time I try and use my function, I'm going to run my tests. But this is basically, I've got this function that does a stupid thing, which is just it takes a number and it adds 1 to it and spits out the result. So I have a describe block, and I have to give that a string label. So I have to say what I'm describing. And usually what people do is they just give the name of the function that they're describing. So that just identifies that within this block, I'm testing add1, the function called add1. And the describe block creates a scope. So if you're not familiar with PowerShell scopes, there are lots of scopes within PowerShell. And the idea is basically it's a kind of, I'm not going to describe it very well, but it's a kind of container for kind of variables. So variables, functions, aliases, things declared within the scope are only accessible within that scope. So the describe block creates a scope, and that's really useful with testing because you're potentially going to have more than one of these describe blocks, and you want to kind of contain their contents in an individual scope so that the tests that you run don't risk polluting other tests that you need to run further down the script. So then within my describe block, so no open curly brace, close curly brace, I've got two tests, and these are just, they start with it, so it is the Pester command, and then there's some string, and as somebody else said earlier when they were talking about Pester tests, this should really be fairly English-like. It should describe in English what you expected the successful outcome of your test to be, because that string is going to be printed when your test runs. And then we're running my function, so we're calling my add1 function, we're sticking 1 as an input into it, and then we're basically piping the result of that to should. So should is the third Pester command here. And then we're using an assertion. So should supports a number of assertions that are basically ways to evaluate that your result is what you expect. B is the most frequently used one, but there are lots, and I'm not going to cover them all in this session. You kind of need to go look at the wiki.
So one thing that I had a bit of trouble with when I was learning Pester was I didn't get that describe, it, and should would just PowerShell functions because it breaks the naming convention completely.
Yes.
So
you're absolutely right.
Special, like describe could be, should be verb noun.
Yep.
And then dash name, dash script block, right?
You're right. Yeah. I mean, dash B really should be dash EQ.
Yeah.
But what they've done is they've written it in a way that makes it kind of English readable, and that's why it breaks that PowerShell convention of kind of verb noun for the names of the commandlets. These, as you say, these are just Pester commands, but they've been written in a way so that somebody non-technical could read this and can kind of understand what's being intended. So yeah, we've got 2 tests. The other thing to say about the it block, so again, it, curly braces, contains this code inside of it. Anything you put inside an it block, you can put any code you like in that. And basically how Pester decides whether or not a test has passed or failed is whether or not an exception is thrown. So any code inside that if block that throws an exception will cause the test to be considered a fail. So basically that's all the should does. The should block evaluates whether the result of add 1, 1 is 2. And if it's not, it throws an exception. It throws a great exception because it tells me a bit more detail about why it failed, where it failed. But really, that's all we're working with here. We're working with standard PowerShell exceptions. So this is why you don't really even have to use should if you don't want to. You could design your own assertion that kind of, you could put an if block in that says, hey, if it's not 2, then throw any message I like, and still cause the test to fail. But by using should, so you're making your Pester tests read kind of like the English language. So I've got a second test here. I'm testing whether or not it also works with negative numbers. This is where it all goes wrong.
Can I just ask a question?
Yeah, sure.
So if you have the add 1, 1
Yep.
should be 2, so is that like an example of, imagine your dollar number is 300.
Yep.
Is it going to test add 1, 1 should be 301?
No, well, I could have made my test 300 and then say it should be 301.
So how do you, in that case, it will only work for a specific?
Yep, you're absolutely right, and this is one of the slightly alarming or worrying aspects of unit testing. You have to decide, you the developer have to decide how many ways in which you want to test your code.
Can
Now,
you do an if there? So if, for example,
um,
add 1, 300 is
yeah, you could.
Should be 300 plus 1, but then you just.
You want to be careful not to just recreate your code in your tests.
Exactly.
Yeah. I mean, as I said, you can use loops, so I could put in like 1 to 300 and pipe that into a for each, and then test my code test that my code works against 300 different numbers. It would make my tests obviously a lot longer to run, and it will be overkill. The idea is, and as I cover a little bit later, the idea is to have some fixed scenarios that prove your code works with some fixed inputs, that you get some fixed outputs. That's kind of the idea. As you say, it's only proven that it works with 1, but if it works by making 1 become 2, then there's no reason why it wouldn't work with 300 and 301. That being said, I've declared this as an int, so there is a limit. It's not going to work with non-integers. It's not going to work over the size limit of an int. So there are boundaries, and again, you just sort of got to be happy that, okay, this function is only for adding a single number to a small number, and you have to decide what is reasonable test to prove that your code works within the boundaries that you expect. And actually a bit more on that in a sec. So let's run this. So there's a command, Pester has a command called invoke Pester. You can just run this script directly. You don't have to use invoke Pester to run your tests, but you get a nice summary if you run it with invoke Pester, and there's some other switches around invoke Pester that allow you to sort of get more output than you would if you just run your scripts directly with PowerShell. Note also that I've named it .test.ps1. This is an important standard to follow, because invoke Pester, if I just run it on its own, any files named .test.ps1 under the current directory, or any subdirectories, because it recurses, will be called by Pester. So that can make a real quick way. When you've got a whole set of tests in different files, you can just run invoke Pester, and you know that all those tests are going to run. But I want to run just this one specifically, so I'm going to name it. No, I didn't. I named the. Okay, so so there's the result. So invoke Pester has run my test, and basically what we've got here is we've got our text from the describe block. And we've got the results of our tests, so we get a little plus symbol to show that they passed. And then that text I put there is what gets spat out, which is great, because that shows me what test was being run and that it passed. This number on the end tells me how long the test ran for, which is not always useful, but sometimes if your test scripts are taking a long time, it can be interesting to see what specific tests are using up the time. And then you get a summary at the end saying how many passed, failed, etc. Now, as I said, I whacked int in here. I didn't do this originally, because I didn't think it was necessary. So I had this without int. Does anyone think this will now pass or fail? That's a trick question, isn't it? Let's run it and see. And basically what happens is it fails. which is great. Like I only had the one test to start with, and then I added the second test because I kind of thought, oh, I wonder if it works in negative numbers. And by default, it doesn't. And you can see in the output exactly why it doesn't. Pester's been really great. As I say, the detail in the exception's been really useful to me because it's told me that it expected the result to be 0, but instead I got -11. And the reason I got -11, obviously, is because it's done like a string combination. It's taken -1 and it's added 1 to the end of the string. So because of that error message, I really quickly went, oh, OK, I can see what's happening here. When I've given -1 as the input, it's treated it like a string. And so, OK, I can work around that by defining it to be int. And then it will be treated as an integer input. And also, if I try and send this a string input, it would throw an exception because my function doesn't accept non-integer input. And again, that's a good idea. Don't design tests. Like, there's no point me adding a test here to say, does it throw an exception when I give it a string? Because I know it's not going to work with strings because I've designed it that way. So yeah, think about testing the edge cases and not necessarily testing every case. It's better to use PowerShell to enforce certain standards than have to kind of test for edge cases. OK. I've got a slightly more real-world example. So this is basically again, still a pretty simple function, but this is called remove-temp file, and then it accepts a path. And all it's doing is I want it to clean up my temp directory. So I want to clean up temp files from a specified directory. So it does two things. It grabs any files that are called star.tmp, and then it pipes them into remove item. So my test for this, again, now I'm describing remove-temp file. And I want to say, OK, well, I expect it to return nothing because remove item doesn't return any output. So I can't really test for a result. This doesn't return any object output, so I can't test for object output in my result. But I can test that it didn't return object output, so I expect the output of it to be null. So if somebody modified this function and created some extra line of code that threw out some object output that you didn't expect, and that can happen sometimes, like if you use new item, it can send something out to the pipeline, the path of the item that's been created that you don't expect it to. So I'm making sure that my function doesn't return anything. That's what I expect it to do. And then I'm using the dash exist assertion. So this is a different assertion on should. It's just basically you give it a path to a file, and it just says if the file exists, then the test pass. Except for I've used -not, and this is another thing you can do with should. You can reverse any assertion you can negate by just adding -not. And again, this reads really like English. Oh, and before I've started this, I've created a file. So I've made sure that there's this file under my /temp directory to be found by my tests. Now that's really important. I'll come to that in a sec. The last test I do is I test that my function doesn't throw an exception. So I don't expect it to just error out. And so again, there's an assertion for that, which is called throw. And again, I'm expecting it to not throw. And the only thing to know about when you're using throw is you have to pipe it a script block. Whereas previously I've piped it the result of my function, I have to give it a script block as input. That's something that will, when you're new to Pester, will just catch you out.
So I used to use that a lot. I still do actually when I'm just doing like a single test to check that it doesn't go wrong. But I've seen people say that that's a redundant test.
Yeah.
Because if in any situation, if it throws an exception, it will fail the test. So you don't need to check specifically for not throwing an exception. Yeah,
that's certainly true. I'm just going to refer you back to my not the foremost expert Pester slide, but no, you're absolutely right. And again, it comes back to decide for yourself what's a useful and not useful test. I really just sort of added this to demonstrate that throw is something that you can test for, but to do so you need to pass a script block. But you're absolutely right. What you can also do with throw is you can specify an explicit exception. So, I mean, this can be useful if you've got a bug in your code that causes an exception to occur. You could add a test that tests for that exception occurs, and then fix the bug, and then your test will prove that exception no longer occurs. That's another good approach. But yeah, this pattern here is talked about in the Pester documentation, and this is an example of arrange, act, assert, and this is a pattern that you tend to have to use, or you might want to use when you're testing, which is that you arrange some you arrange some scenario, right? So I've arranged for there to be a file called test.temp under my temp directory. I've acted on it, so I've run my commandlet on my temp path, and then I've asserted what result I expect. I expect these different assertions to be true. This pattern is when you're doing unit test, you often need to arrange some scenario, create some setup, act upon what you've set up, and then assert the results of that. Now, this is fine, but I can only test with this code. I've broken my rule of unit testing because this code does two things. This code pulls some files from the path I give it, and it also then removes them. So I can't test explicitly that the files that it's pulled are always going to be star.tmp files. And so to do that, I need to do something called refactoring. And refactoring is just the idea of changing your code without changing its behavior. So it's reorganizing your code, perhaps breaking it into smaller parts, but the end result of your code is still the same, and also the way that users interface with your code is still the same. So you often, when you're writing Pester tests, if you've got like an existing PowerShell function that's like 100 lines of code and it's doing 20 different things. If you want to unit test that function, you'll probably find that you'll need to go through some refactoring. You need to start looking at it and go, okay, what's the individual pieces of this? Maybe the first bit, it talks to an API and pulls some data, and then maybe there's a bit where I do some transformations on that data where I convert it into, change the dates or something. And each of those distinct, those actions that your code are going through, if you can break them into individual functions, then you can test each individually. So this is an example of having refactored this code. So now I've got a get-temp file function that pulls my temp files, and now I've got my remove-temp file relying on that get-temp file function in order to retrieve the files. So I haven't changed the way users use my remove-temp file function. They still just run remove-temp file and give it a path, and my other tests can still reflect that. But now I'm able to test the file retrieval part independently. So here's how I would test that get-temp file part. Again, I'm arranging for there to be two files on this occasion, test.tmp and tmp.doc. And these I'm putting under a path called test drive, which I'll talk about in a moment. And then I'm asserting that, well, when get-temp file runs, I should only get temp files back. Now, if you've been paying attention, you might have noticed I've created a bit of a bug in my code. So let's just see what happens when we run this. Oh, by the way, I love VS Code for Pester development in particular because of this split pane view. Again, you might find that you write, I write my code first and then I think about testing it afterwards. I don't do the test-driven development concept, but it's really nice once I've written my code to kind of stick it on the left-hand pane and then be able to start writing Pester tests, and I can kind of go through my code line by line and go, okay, how am I going to test each aspect of this? So, okay, here's that refactored version, which apparently I've already fixed in a previous. Let's put my bug back in. Sorry?
You're just creating a function to run a one-liner.
Yes, which again is. No, not just for the purpose of a test. This is, again, a somewhat ridiculous example. So I don't think I'd ever write this in real life unless I had some real level 1 help desk people that I didn't trust to be able to clean up temp files, and maybe I'd give them this tool. But I don't think I'd really wrap get-child item in a function. I'm not just doing this for testing. What I'm saying is that if I want to be able to test this code, I'd break it into these two functions. And what I'd maybe do, if it was a more complicated piece of code, this would perhaps make more sense. But I'd still have these two functions, but I wouldn't necessarily expose this get-temp file function to my end users. So if I was publishing this as a module, you can have the concept of private and public functions. So you can have some functions that are internal, that are only used by the module itself, and some functions that are actually external and executed by the end user. They're exported commands. So I wouldn't export the get-temp file command. I just rely on it being used by remove-temp file. But yeah, this isn't just for testing. This is I'm basically saying, okay, well, this is just how my code will work now, because it means that these two pieces are independent. Let's say it's a somewhat contrived example, but let's run this just to see that it fails. Oh, it doesn't. Why don't you fail? Oh, again, I've run the wrong. There we go. So I've run the test file now. So again, it fails because it basically says, well, I only expected to get a .tmp file back, but actually I got a .tmp file and a .doc back. And again, I like Pester for being really explicit. It's telling me exactly what's gone wrong. Okay, again, this is contrived. I've created a scenario where there's a file in my temp directory, in my test drive directory that has temp in its name, and my bug, therefore, it causes that file to come back. But yeah, thinking about I was able to test this part of the code individually. So before I've even gone as far as removing any files, I've proven that this part of the code is actually going to return the wrong set of files, so I then don't necessarily have to proceed with testing the removal of files. So yeah, refactoring is quite often a fundamental part of unit testing Pester, because your code is often big combined pieces that you need to break down into smaller pieces to make them independently testable.
Yep. Your tests break if outside of the it block you screw up as well? So if you got like an access denied on the new item? I
think it does, yeah. I think certainly you get some error output when you run invoke Pester. If you have something, yeah, if new item through, if I was giving this a bad path, as you say, like if I tried to do it on, I mean, I haven't got a C drive, for example. Let's find out. Yeah, I mean, what you get the more standards. That hasn't caused my test to fail because it wasn't within the it block, but you can see the standard exception. Okay. So that's refactoring. So I showed test drive in the previous example. So I suddenly and unexpectedly started using this path called test drive. This is something else that Pester provides for you. So every time you use a describe block, Pester creates you a test drive, which is a mounted PS drive. And all it really is in reality is it just creates you a randomly named folder underneath your system environment temp directory. And that just then is this safe space in which you can do file type manipulation. You can create files, you can remove files, and it's a nice place then to stage my test files. So previously I was using /temp, but for all I know, there could have been other star.tmp files in my /temp directory, and that would pollute the results of my test. I can't know for sure that that area is going to be consistent. By using test drive, it only exists for the life of the tests. So I create files in there. I know that those are the only files that are ever going to exist. Equally, if my code's broken and I've put some horrific bug in where when I run it, it goes and removes every file on my file system, I don't want that running in a path that is real on my system. I'd like it to be a testing path. So test drive is great. The other thing is Pester automatically cleans it up, so you don't have to worry about removing files afterwards. As soon as the describe block ends, everything in it gets wiped away. Every describe block, I believe, gets its own uniquely named unique path. Thank you for nodding. And the other thing it will do is if you can have context blocks, which again I haven't covered, but this is an optional block you can have inside of your describe block, which again create another scope. So it can create another scope within which your tests run. So really useful when you're testing your code in different ways to have each in an independent context means they're running in different scopes, and again it stops tests from polluting each other. But if you use test drive within context, what Pester does is it kind of keeps a record of what files were there before, and any new files you create in that context, it then removes once you've left that context block. But that's not doing any sort of clever snapshotty type technology to absolutely revert it to the same state. So you do have to be a bit cautious if you're relying on that if you modified a file while it was in context, it would still remain changed. Okay, so mocking. So yeah, this is Ed Sheeran with his waxwork, and while it would be great if Ed Sheeran would stand in Madame Tussauds every day, he's probably got better things to do. Mocking is basically a facet of unit testing. So this is not unique to Pester. Like most test runners will do this concept. And basically what it does is it's the idea of replacing real commandlets or functions with some fake or simulated one. And that's useful for a number of reasons. One can be that your code is relying on some missing external resources. So you might be needing to use the AD commandlets, and where you're testing your code, the AD commandlets don't exist. You might have an API that you need to talk to, and where you're testing code, you can't reach your API. So you can kind of fake out those resources that are missing and still allow your test to pass. your code might make, so like my remove temp file, might make some destructive or permanent changes. Or like, maybe I've got something that deletes users in Active Directory. Just for the sake of testing my code, I don't necessarily want it to go start trying to remove users in Active Directory. So mocking is a way to stop your code from making destructive changes that you don't really want to happen, but still be able to test it as if it was running for real. And then the final reason, it can be a little bit difficult to get your head around, but if you've got multiple functions and you've already got a comprehensive set of tests for one function, and then you use that function in another function, there's no reason for it necessarily to run for real because you've already tested it elsewhere. So it can be helpful to mock it away so that you're not having to handle all of its internals when you're testing the parent function. That's not very easy to explain, but yeah, the point is don't test things twice if you can avoid it. Finally, I haven't put on this slide, but the other real reason for mocking, real useful thing, again, like with staging files into my test drive, by using mocking, you can create fixed results for things. So, say there's an example that I saw when one of the Pester maintainers was running a training session on Pester, but he had something that was creating a file name based on a date. He couldn't use getDate as part of his test because the date would always be different. So he basically had to have a way he mocked getDate so that it returned a fixed result. And by doing so, he created this fixed universe in which his tests run. So yeah, mocking can be another way with which to create fixed scenarios so that your tests run in a consistent way. So here's an example of using mocking. So again, I'm still working on that remove temp file silly function. But I've mocked away remove item. So remove item now. Basically, Pester, when my test run, injects remove item into the code. So when it goes to run the remove item commandlet, my mock runs instead. Now, there's these empty braces after this, which aren't mandatory. But anything I put inside these braces will be what now happens when remove item runs. And I just want nothing to happen. I want remove item to just not run. And so I've mocked it away. I've still created my 2 test files. On this occasion, just to show that you can do this if you like as well, I'm running remove temp file before my it block and storing the result of it into a variable, and then I'm just testing that variable in my test. So again, I'm testing that it returns null, but this is a new assertion, so I'm not using should anymore in this test. I'm using a new Pester assertion called assert-mock called. And basically what I'm saying here is I expected the mock to be invoked one time and one time exactly. So not 2 times, not 0 times. If you don't specify exactly, it'll be kind of like 1 or more. And if you don't specify either of these, it'll just be any amount of times. But I only expect remove item to run once. And the reason for that is I only expect one of these files to be removed. I only expect test.temp to be removed. So if it's going to remove temp.talk, remove item will be called twice. So we can look at that for real. So there's my code again, and here's what I just showed you on the slide. So if I run, I'm going to try and get it right first time this time. Oh no. Okay, example 4. So you can see my bug's still in this code, my fudged extension. So it's shown that remove item, this is me testing the remove-temp file function, and it's shown me that it's still failing because I expected remove item to be run once, and because it tried to remove 2 files, remove item ran twice. So although remove item hasn't actually removed any files, which is great, because if I was testing this on some real system, I've neutered its ability to make destructive changes, but I've still added a test that gives me the ability to catch that my code has a bug. So I should just be able to, again, put that fix in, run my tests, and now they pass because remove item only runs the 1 time as I expect. Okay. So this is a little more advanced, but sometimes you want to mock commandlets that aren't present. So as I mentioned earlier, you might want to be able to mock the AD commandlets, even though you don't have the AD commandlets. And Pester will throw an exception when you try to do this by default. It will basically say you stick a mock in for something that isn't currently in the system, and it will just say the command is not found. But you can fudge your way around this by basically creating faking the existence of the commandlet, so creating an empty function that's called get-ad-user, and then mocking it afterwards. And the mock will work because I've created the function called get-ad-user. Now this is used with care because it can get complex because when Pester mocks a real commandlet, it's also mocking its kind of inputs, its parameters, and other things about it. So bear in mind that when you create these fake functions, you're not necessarily mirroring the exact configuration of that function, but it can be a useful way to work around where you need to test where something doesn't exist. So let's just show you that in real. So this is going to get a bit more serious now. So now I've got this remove-ad disabled user. So I'm giving my help desk people a tool to remove disabled users from Active Directory. They can specify the number of days that user it's been since that user last logged in, but by default it's 30. And actually, although I'm breaking the convention here because remove type commandlet shouldn't normally return any output, but if they stick -output users on the end, it gives them kind of a report that says, well, these are the users that I removed. So I use get-ad-user to filter for false, enabled where for disabled users. And then, I'm sorry that I used a backtick here, it just wasn't wide enough. But then I filter my user list down further, basically say the last logon date for those users has got to be more than 30 days. And then if there are no users, and I've used the verbose switch, I get a little message that says, just so you know, I didn't do anything. And if there are users, then I pipe them to remove user to remove them. And again, if I've used verbose, I tell my user how many users I've removed. And as I say, if they've used that output user switch, then I just spit out the list of users that were removed. So this is again a slightly more realistic tool that you might write if you want some automated way with which to remove disabled users from your AD. Now, I do not have the AD command. This is a Mac. I don't have the AD commandlets installed here. But what I've done is I've declared two empty functions for get-ad-user and remove-ad-user, and then I've mocked them. Now, this is an example here. I haven't mocked this one as empty. I've basically mocked that it's just going to return two PS custom objects. Now, as I say, this isn't exactly the same as the sort of result you'd get from get-ad-user because get-ad-user returns an object of a specific type, an AD-user type. And I can't do that because I don't have the AD commandlets, so I don't have that type to work with. And of course, it returns more properties for a user than I've specified here, but I don't care. These are the only ones I need to work with for the sake of testing. But you can see two PowerShell objects will be spat out by this, Tony Stark and Pepper Potts, and they've both been fired. And one of them last logged on 35 days ago, and one of them last logged on 15 days ago. And so I should only then be removing one of these users. Only Tony Stark should be removed from the system. So again, I've mocked remove AD user, so it doesn't really exist. I didn't need to necessarily neuter it, but I've mocked it because I would still mock it, although I haven't done so here. I would still mock it so that I can use a cert mock called to test how many times that commandlet was called. If I don't mock that function, even though it's fake, I can't use a cert-mock called to check how many times it's used. But I've just got one test here. It should just, as I say, it should just return one user. I'm running my commandlet with the output user switch, and so I expect it to only have used, only return one user back. So again, let's run this, and it does. So it only returns one user. So yeah, a little bit more advanced there. My mock is now spitting out some real PowerShell objects instead of just doing nothing. And I've not got the AD commandlets. I've got a tool here that is used to manage AD. If I was using this in somewhere where these AD commandlets did exist, it should in theory work. I don't know if I've really tested it, but I think it works. But even though I'm on a Mac, I don't have the Active Directory commandlets installed. I've still been able to test it. Now this can be really useful because, particularly when you get into that world of an automated pipeline, when you check in a change to your code and it goes off and tests it, it's going to test it on some build server or some cloud service perhaps that doesn't have the AD commandlets, doesn't have access to your Active Directory. So being able to kind of mock away these things means that you can still test your code even though you're not in anywhere near your environment or necessarily have all of the things your environment contains. Okay, so this is the last real section that I'm going to go through, and that's code coverage. So yeah, code coverage is a measure of how much of your code has executed when your tests ran. So basically, it's a way of knowing, and beware, it's not necessarily every line of your code, but it's every line of your code that is a command that does some sort of execution. Pester can give you a report that says, well, when I tested your code, these lines of code, these specific lines of your code weren't actually called. And so it's just a useful way to work out where you might need to add some new tests. The reason why this can happen is because your code is going to contain a series of logic. It's going to have if statements and else statements or try catches, thank you, or loops. There's all sorts of different logic that's going to exist in your code. And as a result, your code's going to have multiple happy and unhappy paths, different ways in which it can fail, different ways in which it can succeed. So you need to therefore have tests that test your code in those different ways to make sure that every path is traversed. So code coverage, it's hard to just, when you've got particularly complex code, to know whether you've covered every logical place where your code branches. And code coverage can help you to do that. I will say, as I've said here, 100% code coverage doesn't mean 100% working code. You can have every element of your code run by your tests and still have a bug in there that you haven't caught. And getting 100% code coverage isn't always useful. Sometimes the code coverage reporting will say there's one line of your code that you didn't test, and you can look at it and go, well, there's no point testing that because it's some redundant part of the code. Because there are reasons why you might sometimes not test certain lines of your code.
So what I use it for, you just mentioned it because you've got a redundant line of code.
Yeah.
If I can't find a way to test that code path, it should be removed.
Yeah.
It's effectively dead code.
Yeah.
So I find it really good, because always when you're writing code, it's like, I'm not using that, but it's some kind of error checking or something, and I'll just leave it there.
Yeah.
And all it's doing is complicating your code, and I use it to help me simplify. If I can't test it gets deleted.
Yeah, that's certainly a good answer. And equally, but there are times where like I've put a code on the end of a parameter, for example, so I'm sort of my default value for parameter has some code in it. And I just know that I don't need to test that aspect for some reason. So yeah, don't write tests just for the sake of achieving 100% code coverage. If you don't need to get 100, if you know that code is pointless, don't be a slave to the percentage. Because bear in mind, every test you write is something extra to maintain. So yeah, bear that in mind that don't just be a slave to the percentage. Okay, so how do you use it? It's slightly complicated in that you run invoke Pester with the code coverage switch, and then you need to send it. It's not a switch, sorry. It's a parameter which you need to feed a list of files that you are testing. So you need to. It doesn't work out by default which of your files your tests are testing. You need to send it a list of files, and one of the easiest ways to do that is just to pass it a collection of star.ps1 files through get-child item, ensuring that you're not also including your test files themselves. So if you're, in this case, my module has all my PS1 files underneath it and my test files live somewhere else. So yeah, you need to feed it a list of the code files, and then obviously you need to run Pester, have Pester execute the test files that relate to those code files. I'll show you an example of this. Okay, so let's open them again. Okay, so I think actually this is the same code as before. Yeah, actually, no, it's not. I should use 5. Okay, 5 and 5. Yeah, there's a reason why I put this up here, because it was just long to type. So this is my invoke Pester command. Again, I'm running specifically my number 5 test file, and then in code coverage, I'm telling it explicitly that this is I want a code coverage report for the file that test file tests. So if I paste that here, paste, don't paste that. Okay, cool. I hate the way paste works with VS Code. Okay, so this is the report you get. My tests still run. You get, I've still got my describe block, I've got my summary, but then after that I get a code coverage report. So I get my score, 92%, and it basically explicitly says in this file, this function, line 19, we never called write verbose. So let's look at line 19 in my file, and I go, oh, okay, if there are no users returned, then this write verbose gets called. Well, in my current set of tests, at least one user always gets returned. So I've never tested for the scenario where no users get returned. So that's why I've now got version 6 of the code. So version 6 of the code hasn't changed, but in my tests now, I'm using a context block to basically have an additional test that, well, what I've now got, I've declared my mocks again. Well, I've mocked getAdUser again. So even though it's mocked up here, I'm now mocking it here. And because I'm mocking it within my context block, thank you, that's the mock that gets used by my test. And as a result, when my test runs, getAdUser will now return no users at all. It just has an empty output. And I've also mocked write verbose purely, as I said, because I want to be able to assert whether write verbose actually got triggered. So now I'm running my code with the dash verbose switch, and then I'm asserting whether write verbose is returned, and it should return. Oh, again, wrong file. Okay, so my tests all pass. But now if I do my code coverage on this, I should have covered that one scenario that wasn't previously covered. Yeah, so now I get a score of 100%, and it's not spitting out any lines of code that have been missed. So that's code coverage. That sort of brings us to the end, really. There is more to Pester than I've covered, but with what I've shown you, you should now have enough basic knowledge. And just go out there. I'll put these on GitHub. They're already in GitHub. But have a look at other people's Pester tests to use as a point of inspiration if you don't remember anything about the syntax. Have a look at the wiki, because Pester has got a really detailed wiki. So you need to go to the repository and then go to the wiki tab of that repository, or just that URL there. But every function command of Pester is really, really well explained with examples. And then if you need any other help, I'm happy for people to contact me. There's also a Pester tag on Stack Overflow. And Stack Overflow is a really nice place to work on PowerShell and Pester problems because of the way that it allows you to kind of present and format code and work on it together. And there's a really nice community that will help you tag it both Pester and PowerShell to get the most exposure to it. There's obviously the PowerShell log forums. There's a Reddit subreddit of PowerShell. There's a PowerShell Slack community. But lots of places to get help. Yeah, and that concludes the talk, really. Does anyone have any questions? Everyone wants to go home. Cool. Well, thank you very much. Thank you.